Since we already know a lot of it, it's going to seem familiar, but the independent variable is defined as the inputs or the x values. These independent variables do not rely on anything else. It's like the chicken that then became the chicken nuggets, or the fish that then became the fish sticks. That's what we're inputting into our function machine. It controls what the output is. And the dependent variable is our outputs. Those are our chicken nuggets. Those are fish sticks. It's what comes out of the function machine. And we're going to use y's to represent our dependent variables, because it all depends on what's put in. That time when we put fish and steak and chicken and the toxic waste and the elephant in, our output was the spam.
Why?
They're just scoring on spam. Now, a relation and a function are two words that kind of go together. You guys talked about this last year, and some of you answered questions about it after our test last class. Is it a function or not? You remember answering those questions? Yeah. Does this represent y as a function of x? Those are the same types of questions we're going to use, but we're going to use the phrases function and relation. So a relation is any set of inputs and outputs. All of the functions that you would have said not a relation or not a function to. When you answer not a function, you're actually calling them relations now. A function is a type of relation. It's a very specific relation that has a one-to-one relationship, or a one-to-one relation, which is a fancy mathematical way of saying the x values cannot repeat. Which is what you probably learned last year, is that if it's a function, the x values cannot repeat. Same thing, just instead of saying not a function, we're going to call the not a functions a relation. Then going along again with your independent and dependent variables or values, which is like that second question on your pretest where it asks you what were the independent and dependent values on that scatter plot. That's really asking you for the domain and the range. Domain is defined as the set of all input or x values. So just like on that second one, you might have listed out all of the independent values from that graph. That's really talking about the domain, and that's what we're going to call it now in this class. And the range is pretty much just the opposite. Instead of being the set of inputs, the range is the set of all outputs, or y values, for our data sets. Again, really just talking about the independent and dependent variable, the inputs and the outputs, but we're going to use the phrases domain and range to talk about them. Now, quick review from 8th grade. To determine if a relation is a function, we kind of defined it already, but if we're going to check and see if a relation is a function, all we have to do, or the rule we're going to follow, is we have to check and make sure that the x's do not repeat. The x's cannot repeat in a function. The x's cannot repeat in a function. You'll see the phrasing y as a function of x. That means we're looking for the graph maybe that has the only ones that do not repeat. So we can do this from a list of coordinates, a table, a mapping, or a graph. And we're actually going to practice all of those right here. And these are going to go pretty quick, so hang on with me. The very first one, if we look at the x's and y's that are given to me in these coordinates, we only care about the x's. I don't care about the y's right now if we're just asking, is it a function or not? Do any of the x values in this particular example repeat? No. I've got -2, -1, 0, 1, and 2. None of those are repeated. So we're going to put an F next to this one for function. This is a function. Woohoo! Yeah, that second one's not a function because if you look, x and y, oh, look, those x's repeat. The 4 right here repeats. So instead of saying not a function, which is maybe what you did last year, we're going to call these relations. Okay. It is not a function. So if you wrote down not a function, true. but we're going to call it a relation. Then we have our tables of inputs and outputs. These are super nice because they're already organized for us. We are only looking at the input values, which are here. Do any of the input or x values repeat?
Yes.
Yeah, right here. We got repeated zeros. So do I put an F or an R next to this? R, and it stands for?
Relation.
Relation, yeah. Or not a function. Mappings. We've seen mappings before, correct? It's the bubbles?
Yes.
Okay, so what mappings tell us is coordinates. This one's saying we have the coordinate -1, 4, the coordinate 3, 15, and the coordinate 11, 15. Did any of my x values repeat here? No, so what can we call this? A function. Very good. Now, does it matter that my y value repeated here? No, I'm okay with the y's repeating. I don't really care. I'm looking at the x values. If we look at the second mapping, we have the coordinates 1, 3, 2, 4, and 3, 5. Did any of the x values repeat? No, so this is also called function. Now, don't write this down, but I want you to watch. I'm going to show you what this would look like, a mapping would look like if it's not a function, just in case you've never seen. Maybe this happens. So now if I listed out my coordinates from this mapping, you'd have 1, 3, 2, 4, 3, 4, 3, 5. You see how I've repeated saying 3 out loud? It has 2 arrows popping out of it, right? That's when it's not a function. That would be called a relation. But we don't have that. So, it's not going to let me erase. There it goes. Okay. Then we have these 3 examples. You guys last year probably learned about what's called the vertical line test. Did y'all learn about that?
Yes.
Vertical line test. Vertical line test, that thing that you can draw a bunch of lines on a graph. And what happens if perhaps like this, we draw a vertical line and this happens? It's not a function, and so we're going to call it a relation. Very good. The vertical line test is a bunch of lines you can draw on a graph. And if your line ever crosses that graph more than once for any particular vertical line, it is not a function, so we're going to call it a relation. You guys have these 2. Do them really quickly on your paper. It won't take you very long. So let's see. If I draw a bunch of vertical lines through this first one, did any of these vertical lines cross that straight line more than once? No. So what do we call this one?
Function.
Woohoo! But if I look at that circle graph and I immediately, doesn't this vertical line cross it twice?
Yes.
Yeah, so I don't call that a function. I call that a type. Awesome. You guys got it. Our main goal of today, once we got past is it a function or not, is actually to describe discrete data sets. That's the domain and range that we're going to be working with today. Next time we'll talk about continuous, but today we're going to be working with discrete data, which is like scatter plots and that type of data. So it's a lot like what you've done last year. So for our notes today, we're going to write down that discrete means disconnected. If you're looking at a graph and you have a bunch of disconnected dots are discrete, which is super nice that disconnected and discrete start with the same 3 letters. So it's going to help us remember that anytime we have a scatter plot or a bunch of disconnected points, that is a discrete data set. Also, what we're going to have to do is look at items in real life, things that we would actually do math for, and decide if it's representing discrete data.
Like design.
Like what?
Design.
Like designing our own problems, yeah. But when we're talking about discrete things, we're going to be talking about things we can count. Okay, next time we'll be talking about things we can measure, but discrete information is things we can count. So for example, if I was measuring the number of students in the school compared to the amount of trash we have at the school, okay, that's something I can figure out in math. I can find data sets for that. But can I ever count like half a person? No. If you have to have whole numbers, if you cannot have fractions, no fractions, that's a huge indicator that we're talking about discrete data, okay? If I give you an example of a situation where we are selling tickets to go to a concert, can you ever buy half a ticket? No, that doesn't make any sense. It's not a thing. That wouldn't be valid. So tickets are something that are discrete data. You either sell a whole ticket or you don't. There's a whole bunch of other items that we can use discrete data sets for, like perhaps boxes, a number of boxes, maybe the number of suitcases that you take on a trip. Okay, maybe the number of teams in a competition. All of these things, you have to have a whole item. You can't have fractions. These are going to be our whole numbers. We're talking about disconnected data or discrete. So a lot of these problems, you're going to have to think about them in real life. If I cannot take half of a poinsettia, that makes that poinsettia data discrete, because you can't sell somebody half a poinsettia. That's a flower. Now, the main idea here, though, is not just deciding if something is discrete or non-discrete, continuous. We're also going to need to be able to describe, I don't know why this keeps happening. We're going to need to be able to describe this data set. And describing them is where our domain and our range comes in. You see this Dr. XY here on your paper? That's going to be one of those things like inequality man that you see popping up over and over again. Dr. XY is one of my favorite because it helps make this super simple. If we're talking about the domain, we're talking about the x values. If we're talking about the range, we're talking about the y values. So Dr. XY lines it up for us and helps us remember if we're talking about the x's or the y's. Go ahead and circle that on your paper the way I did. So D is over x and R is over y. We're going to be writing that down like a million times in this class, so it's very helpful for you to remember what we're doing. The rule for domain and range is very simple when we're dealing with discrete functions. For a domain, all we have to do is make a squiggly bracket. Okay, not a parentheses, a squiggly bracket. If right now you can't make a squiggly bracket, it needs to look like that, that's okay for now. If you need to make a 3 and give it a little centerpiece, that's close enough to a bracket. Okay, you start with a bracket, and then all you have to do is list the x values in number order, which is least to greatest. And then you close it with another squiggly bracket. That's it. So it's like that question number 2 on our pre-test to ask you the independent values. Probably just listed them out. That's essentially what we're going to be doing for domain is the independent values, but we're going to put them in a specific order and in these squiggly brackets. For the range, it's almost the same idea, but instead of listing the x values, you're going to list the y values in number order, which is from least to greatest. So it's a very simple concept. You will try to complicate it in your brain, so don't do that. It is very simple. The first example we do over here, I want you to put your pencils down. I want you to watch me do this one, because there's a lot of moving parts here if you're like tuned in only halfway because you're trying to keep up with me. The question asks to find the domain and range of the function represented by the graph. Well, I know that Dr. XY helps me remember that when I'm asked about the domain, I'm talking about the x values, and the range is talking about the y values. Cool. That means when I'm finding my x values for this graph, all I have to do is figure out all the x values that I've used. What's the x value of the first point? If this is -2 right here, what's this one? -3, yeah. Remember, number lines go that direction. Okay, here's my next point. What's its x value?
-1.
Okay, here's my third.
1.
And here's my fourth. What's its x value? 3. That's literally it. You've listed out the x values that I've used and made it a domain. You put it in a squiggly brackets in number order, and you're good to go. Pencils down one more time. Let's look at the range. Range is bottom to top. Range is the y value. So I'm going to look, and I'm going to drag my pencil over to the y-axis. I literally just covered up the number with what I wrote. So look before I do it. What number is that? -2 is the first number in my range. That's the value. What y value is there? 0. It's got no height. What's the next value?
2.
And the last value?
4.
I like to think of range as levels. If this was like a house and I'm asking you what story are all these points on, you would tell me the first one is in basement level -2, and then you have one on the ground floor, that's 0. Then you have one on the second floor and on the 4th floor. You've told me the stories or the levels that it's on, that's the whole range. If you have not written this down yet, because I told you to put your pencils down, go ahead and write it. I also like recommend drawing the arrows. It's very helpful to find exactly where it hits your X or your Y axis. And once you've got number 1 written down, I want you to try number 2. I know I'm tossing you in there pretty early, but I want you to try writing the domain and range for the second problem. Remember, we want them from least to greatest in both the domain and the range. But now that you've had some time to think, let's check in, see how we're doing. If we're asked for the domain, Dr. XY tells me those are the X's. So I start with any of the points, but probably want to start with the one furthest to the left because that's going to be your smallest X value. The first number in my domain is going to be -2. Then the next point would be -1. What value is right here, though? 0. Thank you. Yeah. I keep dragging my numbers down. I have 1. And then 2. Are there any more numbers in this domain? No. That's it. You've listed off all the independent values or the domain input values for this graph. Here comes the range, though. I'm going to do it wrong, and I want you to see if you can figure out how you can fix me. All right, so we have 0 at the bottom. And I have 2. Oh, and then I have 2. Then I have 4. And then I have 4. Here's the deal. I did it wrong.
You did?
I did.
A -2 and then a 2.
For the range, -2 is down here. Is there any point down here? No. How do you think I maybe could have done this wrong? Because I wrote down all the points. What's up?
You repeated.
I repeated. So here's the thing. This is a list. I didn't tell you guys this, so I'm glad you kind of caught this. If you went to the grocery store and you had a grocery list, and you're like, I need apples, oranges, bananas, toilet paper, oranges. Didn't I just say oranges twice? And if we're making a grocery list, that's super unnecessary to put oranges on there twice. So it's not really necessary for us to write the range where we have repeated numbers or even the domain. Just list it once, and then we're good. Don't do extra work. So not all the time will the number in your domain, so there's 5 numbers in my domain, and there's only 3 in my range. That's okay. There's only 3 separate levels or heights that these points showed up at. You don't have to repeat in your domain or your range. Okay, so it's a different idea from relation or function. We're not worried about the x's repeating for that sake, because this is a different type of question. When you're writing your domain and your range, you don't repeat the values. It's not technically wrong, it's just not right. So we've moved on to number 3 here. It's still asking you to find your domain and range represented by the table. Since we see domain and range, we write down Dr. XY to help us remember what's what. Domain and range. I'm going to give you all a few seconds to see if we can write down the domain and range for this table. It's very easy. Don't overthink it. Don't overthink it. It's labeled.
Oh.
There it is. I apologize if I'm cutting off your thinking, but let's check in and see if we're going correct. I'm going to do the domain wrong. You're going to fix it for me. Oh, I know. What did I do?
So, 2 things. One,
Yeah.
you didn't put it from least to greatest.
Okay, so I should do this.
And 2, you can't repeat. So you
Oh.
have to take. So it'll be 0, 1, and 16.
Thank you for correcting me. That is absolutely correct. So these are all representing the domain, but like this is the only one that's correct. Because I don't need to repeat, and they need to be in number order. I'm making a list. Let's make it an organized list. In number order with no repeats. Cool. And then the range, don't overthink it. It's super easy. It's just the list of the outputs in number order. Did I do that one right? Yeah. You can't. I stood right in front of you. You can't see. Yeah. Yeah, that one's right, because it's from least to greatest, no repeats. Luckily, it was already in that table that way. Okay, we're going to move on to this question number 4. The only way that we can make this any harder is if we give you domain and range questions in a word problem. But don't panic, because these are all very reasonable. So as long as we think of ourselves as actually doing these scenarios, it's going to make a lot of sense to you. There's a first scenario. The function y equals 30 plus 5x represents the cost in dollars of having your dog groomed and buying x extra services. Okay, so we have an equation here. That seems important. Let's highlight that. Circle, underline, star. And then we also have some defined variables. We know y is the cost and x is extra services. We need to know what we're dealing with here.
Okay.
There are 5 extra services that customers can choose from. So let's say we are literally taking our dogs to this groomer to get groomed. On top of getting groomed, they could also get their toenails trimmed, their toenails painted, their hair did, trained, or what are some other things you can do at a groomer? Get their dyed, yeah, get their dog dyed, okay? Maybe you want a pink dog. So those are the 5 extra services we could get done at this groomer, okay? We need to find the domain and range of this function because we're a consumer. We need to know how much money we're going to spend here. The domain is the x values, where our x values are the extra services. What's the least number of extra services?
5.
The least number of extra services? 0. I could just show up and get my dog groomed, right? So I could have no extra services. I could have 1 extra service. I could have 2, 3, 4, 5. Can I have 6 extra services? Do they offer a 6 extra service? No, so we have to stop at 5 because they only offer 5 extra services at this grooming place. So our domain is only 0, 1, 2, 3, 4, and 5. I can't buy half an extra service. That's not a thing. So I have whole numbers. I have no fractions. And I have the numbers from 0 to 5 in my domain. Cool. Now, as a consumer, as a person who walks into this groomer, I need to know how much money I'm going to spend. That's the output. That's the y's. So what would be the range if I had those inputs? All you have to do to figure this out, plug in the domain. If we plugged in our domain to this function, we're going to get the outputs or the cost of taking our dog to the groomer. Okay? If you take your dog to the groomer, all you're going to do is type in your calculator this equation, but with different values of x. What's the first value of x you're going to use right there? 0. So 30 plus 5 times 0 is... Well, 5 times 0 is 0, and 30 plus 0 is 30. All right, if I buy 1 extra service, we're plugging in a 1 into that equation. So 5 times 1 is 5. 30 plus 5 is?
35.
If I buy 2 services, how much do I spend as a consumer?
40.
If I buy 3?
45.
4?
60. 50.
What? 50. And 5?
55.
Can I do any more in my range?
Yeah. No, you can only go to 5.
I can only go to 5 extra services. They don't offer a 6th one. So I know as a consumer the most amount of money I'm going to be spending at this groomer is $55. That's the domain or the inputs and the range of this function. And we found the range by plugging in the domain. Yeah. So these make sense if you actually think about them in real life. If you're just reading them as if they're a math problem, you're going to be like, what? But if you actually think about taking your dog to the groomer, these are going to make sense. Let's look at one more. I don't know why it's not sticking to the page today. But number 5, you're packing books into boxes. The function y equals 20x. Ooh, look, a function. Let's circle that. Highlight, star, underline. Represents the number y of books. Ooh, there's what number of books is y. That's the output. I can fit into x boxes. There's my inputs. Outputs, inputs. I know what they represent in real life. Okay? I know that I can use up to 3 boxes. Find the domain and the range of the function. I'm always going to write Dr. XY down because that helps me organize my brain and remember that I'm talking about the inputs and the outputs, the domain and the range. Using the same thought process at the groomers, if we're putting books into boxes, what's the least number of boxes I can use?
1. 0.
0. I could decide I don't need no boxes. I just carry them all in my hands. Probably not smart, but I could do that. And then what other numbers could I have in my domain? 1 and
3.
can I have 4?
No.
No, because I only have 3 boxes. Okay? Now we're going to see how many books we'd be able to fit in all of this stuff. How many books I'd be able to move using these boxes. How did we find the range a second ago?
Equation.
Yeah, we plugged it into the equation. We plugged it in. When we plug them in, we're going to get our outputs. Inputs create outputs. So 20x, we're going to be plugging in our inputs there for x. What's the first number in my range?
0.
0. I could carry no books because I'm dumb and I didn't use the boxes. And they all just fell apart. I don't know. And if we use 1 box, what's the most number of books we could be taking?
20.
How about 2 books?
40.
How about 3 boxes? 60. Can I take 4 boxes?
No.
No. So that's the highest number in my range. I know, as a person who's moving these books, that that's the most number I can take before the boxes get too heavy, they start ripping, or like, I don't know, I run out of boxes. So I can plan my trips better to know if I need to take 2 or 3 trips with these boxes to move all my books. Pretty simple. It's just describing these functions with their inputs and outputs, just like you did last year with independent and dependent variables, just in the fun little squiggles and in number order with no repeats.